In the question number 21, steam at 100 degrees centigrade is passed into 100 gram of ice at 0 degrees centigrade. Finally, when 80 gram ice melt, the mass of water present will be. So I need the mass of water present, and given data are latent heat for fusion or vaporization 80 calorie and 540 calorie respectively. Heat of fusion 80, vaporization 540. Okay, so now first I would like to say Q is ml. L is the latent heat, you know the formula. So first I need heat given by steam, and that is equal, by the principle of calorimetry, heat taken by ice. So mLV, V for vaporization, plus C m delta theta, formula of heat, and that is equal heat taken by ice. So m dash L 1. Now m, because you know the value of LB, as I said, 540 plus mass is required, and C is 1. Temperature difference will be 100 because passed into steam at 100 degrees centigrade. According to problem, you will take 100. That is equal 80 into 80 according to the problem. This is I for ice, 80. So when you will calculate, you will get m 80 into 80 divided by 640, you will get 10 gram. So this is the mass, but I need mass of water present. So already 80 was there and 10 from this, so you will get 90 gram. So by this discussion, I can say my option number 3rd will be the right choice. So let's move on. Question number 22. Question number 22. A uniform linear thermometer scale. This is very important line I will use. With its 0 centimeter mark at minus 10 degrees centigrade and 50 centimeter mark at 80 degrees centigrade. Temperature corresponding to 70 centimeter marks is. So in this question, I am going to use this point, uniform linear. You know the straight line equation, y is equal to mx plus c. So first I am going to plot a graph with the given situation. Suppose I am taking here temperature in terms of degree centigrade, and this is 0, 1. A length in centimeter along x-axis. So as per the situation, I will write here minus 10 degrees centigrade in straight line. But question says at 50 centimeter mark, temperature was given 80 degrees centigrade. Right? This one. Now I need only the value of y, slope, x and c. So you can compare. Y you can replace by theta because theta on y axis, and you need m slope. So you will see from 10 up to 80. You can slope, you know slope can be solved by using tan theta. M is equal to tan theta. So I will write 90 because minus 10 up to 80 and perpendicular upon base, that is 50. So 0, 0 will cancel out. You have 9 upon 5. Right? So I will write here theta equal to 9 upon 5 into L minus C is the intersecting point on y-axis, and that is minus 10. So minus 10. So you will get a general equation for the calculation of theta. So this is a very good method. 9 upon 5. But I need this theta at 70. So you can replace L by 70 minus 10. So when you will place all values, theta is equal to 9 upon 5 into 70 minus 10. So we'll get theta will be 116 degree centigrade. So I can say my option number 4 will be the right choice. So let's move on. Question number 23. In the question number 23, Cp and Cb are specific heat at constant pressure and constant volume respectively. It is observed that Cp minus Cb is equal to P for helium gas and Cp minus Cb is equal to Q for oxygen gas. The correct relation between P and Q is. So in this type of question, what I am trying to explain, listen to me very carefully. Cp and Cb are molar specific heat. And you know Cp minus Cb is equal to R, right? And I know the molar specific heat. Molar specific heat is equal to m into molar mass is specific heat. Molar specific heat is given by this. So I can use this relation mCp minus mCb is equal to R. So Cp minus Cb is equal to R upon m means molar mass. So if I use this for helium, so can I say R upon 4 because molar mass for the helium is 4. Similarly, if I use for oxygen, R upon and that is 32. This value is given by the problem is P and this value is given by the problem is Q. So here I can say the value of R is 4 times of P and value of R in this expression will be 32 times of Q. And you know R will be same on both equations. So we can compare. If I compare both values, so we'll write 4P from first, 32Q from second. So 4 8 ja 32. You will get P is equal to 8 times of Q. So this is how you can solve such type of questions. So now my option number 2 will be the right choice. So let's move on question number 24. In the question number 24, an external pressure P is applied on a sphere at 0 degree centigrade that its shape does not change. B is the bulk modulus of the sphere material and gamma is its temperature. Coefficient of volume expansion. To bring the sphere to its original size by heating uniformly, the temperature should be raised by. So we can solve this question because we know that the bulk modulus is given by minus P V delta V. Okay, so we can write like that delta V upon V with the mod minus P upon V. So we can make this relation. But why we are going to make this? Because we need temperature raised by. So if I use the formula of volume expansion and that is gamma is equal to delta V, change in volume, initial volume into temperature difference, right? So now I have the value delta V upon V in terms of bulk modulus. And second one, if I use this relation coefficient of volume expansion, then we can write delta V upon V gamma into delta theta. So this is my relation number 1 and this is my relation number 2. So if I compare equation 1 and 2, then we will write P upon V that is equal gamma into delta theta from equation number 2. So if I go on delta theta, then we'll get P upon gamma times of V. So this is our required value. So we can say my option number 1 will be the right choice. So let's move on question number 25. In the question number 25, a spherical body of radius 10 cm radiate 300 watt at 227 degree centigrade. If the radius is double and temperature remains same, then power radiated will be. So in this type of question, I am going to use the formula power radiated, small e, A sigma T to the power 4. Small e is the emissivity, A is the outer surface area, sigma you know Stephen constant and T is absolute temperature. So according to the problem, because radius is double, So hence surface area will becomes 4 times, because area is 4 pi r square. So when radius will becomes double, then surface area will becomes 4 times. And by this formula and according to the problem, I can write the radiated power is directly proportional to the surface area. As I said, radius will becomes double, so new radiated power will be 4 times of area. सो इनिशियल लेवल पे जो आपको दिया जा रहा है वो है 300 वॉट. चलिए 4 टाइम्स होगा तो वी कैन सॉल्व इजिली. P डैश इज इक्वल टू 4 टाइम्स ऑफ इनिशियल रेडिएटेड पावर. सो 4 into, so that is 300. So you can save your time like that. So when you will calculate, we'll get 1200 watt. So my option number 2 will be the right choice. Let's move on question number 26.